All right, let's do some homework problems. We're going to start with number 8. So again, alpha is going to be opposite A, beta is going to be opposite B, just like we did in the notes. Round each answer to the nearest tenth. Problem 8 is saying that alpha is 60 degrees, beta is 60 degrees, and gamma is 60 degrees. Well, I can already tell you this is not possible. We can't use the law of sines on this. This is an equilateral triangle, right? Everything's 60 degrees, same angle everywhere. We don't know how big this triangle is, right? Maybe everything does have the same length. Equilateral triangle, same angle, same length. But triangle could be this big. Triangle could be this big. Who knows? There are infinitely many triangles. Can't use the law of sines on this. Like this. They're all equilateral triangles. You want to give a little bit more information, but you can just be done right here. Look at number 12. Round this one to nearest hundredth on this one. And 12 says it only wants you to find side A. Find A, and we know capital A is 132 degrees. C is 23 degrees. And little b is 10. So let's draw a picture. A is really big. Let's call this A, 132 degrees. C is smaller, it doesn't matter which one we call it. 23 degrees. And B is 10. B is opposite capital B. And it wants us to find A, which is opposite capital A. So again, for the law of sines, we start with an angle and opposite side that we know. But there is none right now, so we do have to find B in this case. So first, B is going to be 180 degrees minus 23 degrees minus 132 degrees, which is going to be it's 155. That's 25 degrees. Getting too late in the day for me to do math. I'm about 4 hours into videos right now, which I don't know why I'm doing this. That's too long of math, even for me. How much math do you guys do in a row? If you're doing more than 4 hours of math in a row, you need to spread that out. It's not good. But I think a lot of you probably do 4 hours at the same time. All right, I'm gonna use my calculator. My brain is fried. All right, 180 minus 23 minus 132. Oh, it's 25, good. The B is 25 degrees. So now we can use the law of sines. Pick an angle and its opposite side. That's where we're going to start. Sine of 25 degrees is to 10. Same as the sine of 132 degrees is to A. Now we need to solve this equation for A. I skipped a lot of these steps because they're always the same in the review video, but we can cross multiply, or in the lecture video. When we do that, we're going to get A times the sine of 25 degrees equals 10 times the sine of 132 degrees. We don't want to approximate yet. We want to approximate only at the final answer. Divide both sides by the sine of 25 degrees. And now we can type this into our calculator and get an approximation for A. It wanted to the nearest hundredth, so let's type it in. 10 times the sine of 135 degrees, 132 degrees, divided by the sine of 25 degrees. That's going to give us about 17.58. Make sure we're rounding as was instructed, and we're good to go. Let's do number 16 next. Assume alpha is, okay, blah, blah, blah. Determine whether there's no triangle, one triangle, or two triangles. Solve each triangle if possible. Round to the nearest tenth. B is 3.5. C is 5.3. And gamma is 80 degrees. So again, going to draw a picture. It's not going to be a super accurate picture. Gamma is about 80 degrees. Just helps you see things. Doesn't matter which one you call alpha, which one you call beta, but C is 5.3. So that's right here. We need to solve this triangle. What else do we know? B is 3.5. We're going to have to find A, beta, and alpha. Maybe there's two triangles. Maybe there's no triangles. Let's start solving it. Pick an angle and an opposite side. Start with that. Sine of 80 degrees divided by 5.3 is equal to the sine of beta divided by 3.5. That's going to give us sine of beta is equal to 3.5 sine 80 degrees divided by 5.3. Let's use inverse sine or arc sine to find what beta is. So beta is going to be the arc sine 3.5 times the sine of 80 degrees divided by 5.3. And we want that in degrees. It's about 40.5676. And the question is, does beta prime make sense? Right? Beta is in the first quadrant, about 40 degrees. But there's another one, right? This one's beta. There's another one in the second quadrant with the same reference angle called beta prime. And again, does beta prime make sense in this problem? Let's find beta prime. It's 180 degrees minus this. So 180 minus 40.5676, 139.4324. And there were two conditions. Make sure we're not over 180 degrees, and the side lengths. Look at these two angles. We're already too big. This condition is failed. Beta prime's too big. It doesn't work with gamma. All right. And the side length would work as well. Beta prime would have to be opposite the biggest side. But beta prime's not opposite the biggest side, so that condition fails too. The beta prime does not make sense. There's only a single triangle here. We know there's at least one because we found beta. We know there's not two because beta prime doesn't make sense. Let's just keep on solving it. Beta is about 40.6. Again, our final answer only needs one decimal place. We're just using more decimal places for higher precision if we need it. Let's find alpha. All the angles in a triangle have to add up to 180 degrees. Type this all in, and you're going to get alpha. This minus that minus 80. Alpha is 59.4324. All right, or about 59.4. Last thing that's necessary is solve for A. Again, let's use the same pair that we used in the first law of sines. But now we're going to use alpha. Going to use some extra decimal places to get a more accurate answer. And again, you can solve this in the same way. And you're going to get the A is 5.3 times the sine of 59.4324 degrees divided by the sine of 80 degrees. And A is about 4.6. We can abbreviate round this one very quickly because this is the last thing that we need. We're not going to use this for anything else. We don't need as much precision. There we go. That's our answers. You can express your answer like this. It asked how many triangles there were. We answered that. And it asked for us to solve the triangle. Or you could answer by boxing all of these ones. Okay, that's number 16. Let's do number 32. Find the length of side x round to the nearest tenth. Okay, so a triangle like this. This is 25 degrees, 6, x, and 120 degrees. All right. Well, we need to start with a pair that we know. We don't know any pairs, so we're going to have to solve for this angle first. All right. These two angles add up to 145 degrees. So to get to 180, we need 35 degrees more. Set up the law of sines. Sine of 35 degrees is to 6, the same way as the sine of 25 degrees is to x. Cross multiply, and you'll get x times the sine of 35 degrees equals 6 times the sine of 25 degrees. Divide both sides by 35 degrees, and you'll get x is 6 times the sine of 25 degrees divided by the sine of 35 degrees. Approximate that with a calculator, and there you go. Six times the sine of 25 degrees divided by the sine of 35 degrees. You're going to get about 4.42. What did it want us to round to? Nearest tenth. So about 4.4. And again, we didn't check this with the last one, but make sure that these are proportionate. This angle is smaller than this angle. So this side should be smaller than this side. All right, let's do 38. I have so many homework problems in this video. Giving you guys good extra practice. Law of sines can be tricky. Number 38. Find the measure of angle x if possible. Round to the nearest tenth. Again, we have an obtuse triangle here. This is x. This is 37 degrees, 8 and 11. Round to the nearest tenth. Law of sines says pick a pair that we know, 37 degrees and 11. And pick a pair that we want to find out, x degrees and 8. Solve for sine of x, and we'll get sine of x equals 8 times the sine of 37 degrees divided by 11. We can evaluate this by taking the inverse sine. And there might be multiple. So x is going to be the inverse sine of that right-hand side. Eight times the sine of 37 degrees divided by 11. Like so. This gives us an answer in radians. We don't want radians. Convert this to degrees. 25, 95, 62. That is x. Does x prime make sense? Are there two answers here? Did it even specify that this could happen? I think in this one it is specifying that the pictures are accurate. So in 41, for example, it only wants the x prime, that obtuse angle. But in here, it's saying this is an acute angle. This is drawn to scale. That's what it's referring to in this one. So in this one, this is our only answer. And it says round to the nearest tenth. About 26.0 degrees. Because in these problems, the figure is drawn to scale. So even though there are two triangles with these measurements, I think, I'd have to check, but I think there are. Actually, no, I don't think there are. I don't think there are. You think even if you checked, you'd get one of these conditions to fail. But even if it did, you wouldn't have to worry about it. All right, let's do 50. Find the radius of the circle. Well, this is kind of weird. Round to the nearest tenth. It's fun though. We got a circle, or what is kind of like a circle, and then a big 145 degree angle here. This is 3. It wants us to find the radius. Note that the radius is just this. It's also this. This is an isosceles triangle. This triangle can be drawn like this. Again, 145 degrees. This is 3. X and X. So these angles are the same. So 145 degrees plus double whatever that angle is, we can call it theta, has to equal 180 degrees. The 2 theta is going to be 35 degrees. Theta is 17.5 degrees. So each one of these, 17.5 degrees. So we can use the law of sines. Law of sines says the sine of 145 degrees divided by 3 equals the sine of 17.5 degrees over x. That'll get you to x is equal to 3 sine 17.5 degrees divided by sine of 145 degrees. There we go. We're basically done. We've found the radius. Just type it into a calculator. 3 times the sine of 17.5 degrees divided by the sine of 145 degrees. It's about 1.57. Did it give us units or tell us how to round? Nearest tenth. About 1.6 is our radius of the circle. There we go. Let's do one last problem. Let's choose a good one. 60 is almost the same as the one we did before. Let's do 70. Two search teams spot a stranded climber on a mountain. First search team is half a mile from the second search team, and both are at an altitude of 1 mile. Angle of elevation. All right, so it's we have two teams that are separated by half a mile. This is going to be team 1 over here. This will be team 2. Separated by half a mile. And they're at a mile elevation. Think of this whole triangle occurring a mile above sea level. Angle of elevation from the first search team to the stranded climber is 15 degrees. The second one is 22 degrees. All right, so 13, 22. And this is the climber. And we're curious about what's the altitude of the climber to the 10th of a mile. Altitude. Nearest 10th. Why am I putting altitude in all capital letters? Because we need to find this height right here. And then we need to add a mile to it, right? That height of this triangle is how high above the teams they are. But we want the altitude, not how high above the teams they are, okay? So watch out for that one. And this is going to turn out to be very similar to the application problem in the book as well. But this formatting, once you get here, that's the hard part, is getting here. After this, it's like the lecture, and it should be pretty similar. We can either solve for this or for this. Pick your poison. Let's find this big angle. That adds up to 35, so it needs to be 145 degrees is this. Wait, are these the same? Looking real similar here. I might be just losing my mind. So, law of sines. Let's call this y. We want to eventually solve for h. All right, that's too small. The sine of 145 degrees is to 0.5 miles, the same as the sine of 22 degrees is to y miles. What's the visual distance from team 1 to the climber? And you can solve this, and you're going to get that y is equal to half of the sine of 22 degrees divided by the sine of 145 degrees. We're going to want extra decimal places here because we're using y later. Let's type this into a calculator and get some good digits. Half times the sine 22 degrees divided by the sine of 145 degrees. Make sure everything's in degrees. That's very important. And that's going to give us 0.3266 miles. So they're about a third of a mile away visually from the climber. And now we can look at this smaller triangle. Right, y is at 0.3266. This is 13 degrees, and we want to know h. So the sine of 13 degrees is h over 0.3266. And now we can solve for h. Multiply both sides by 3266. Point. This times sine of 13 degrees. Going to give us our answer. About 0.0735. Oh, it wanted the altitude to the nearest 10th anyway. The altitude's about 1.1 mile. It's kind of weird to express this as miles. I don't like this, honestly. I feel like we always express altitude in feet in the United States. But these are the units that it's giving us in the problem, right? Round to the nearest 10th of a mile. All right, so we're doing what it wants. Doesn't mean I have to be happy about it. All right, these are a bunch of homework problems for you. Hope it helps. You can also ask me further questions as well. Have a great day. Hope you enjoy the law of sines. And law of cosines is going to be pretty simple in comparison. A little bit messier, but much more logically straightforward, I think. So enjoy and good luck.